So now we will go for another problem. F of z is given as 1 divided by z minus 1. Okay. So as usual, we will have to find out the analytic one. So we will have z equal to 0, then z equal to 1. Z minus 1 equal to 0. So that will give you z equal to 0 and z equal to 1. So z equal to 0 and z equal to 1. Hence it's analytic in the region between 0 and 1. So we have two factors, 0 and 1. Now we will have to use partial fraction. So 1 divided by z minus 1 can be written as a by z plus b divided by z minus 1. So take the LCM, that will give you a z minus 1 plus b z, which is equal to 1. So first substitute z equal to 0. Z equal to 0. If you substitute z equal to 0, this will go off. Z equal to 0 means a equals minus 1. So a equals minus 1. Second will be z equal to 1. You substitute here, this one will go off. You have b equals 1. You substitute here. For a, substitute for b. So 1 with a minus sign, another with a plus sign. So you will get minus 1 by z plus 1 divided by z minus 1 within this region. Z lies between 0 and 1. Now we will have to use geometric series. As usual, the same thing. Minus 1 by z. This geometric series can be written in terms of summation form exactly like this. Okay. Now we will go for the first one. First one is, what is the first one? First one is this one. First one you have finished. Now we will go for the second one. So z lies between 1 and infinity, the next one. So for that, first you just take 1 divided by z minus 1. Just pull z out. So z out. So 1 minus 1 by z. So 1 by z is less than 1. Okay, 1 by z is less than 1. Correct? Less than 1. So we will have 1 divided by z minus 1, which is equal to 1 divided by the same thing I have written. z1 minus 1 by z. I can write this as in terms of binomial series 1 by z, 1 minus 1 by z to the power minus 1 can be written in terms of z to the power minus 1, minus n. So now we will go for now n equal to 0, n equal to 1, n equal to 2. Correct? We will have to expand. But it starts from, look at this, it starts from 1. So n equals 1, 2, 3. It is not n equal to 0. It's a very important one because according to the condition. Because z starts from 1. Okay. So now 1 divided by z minus 1, which is equal to, we have to start from n equals 1. For that you just replace n equals n minus 1. So n equals n minus 1. So n minus 1 equal to 0, that will be n equal to 1. So n minus, instead of n you have to go with n minus 1. So z to the power minus n minus 1. So that will give you z to the power minus n, z to the power 1. This one and this one will cancel. You have z to the power minus n. So f of z becomes, we have done only for this one. We have kept as it is. Can you remember? We have done only for 1 divided by z minus 1. We have kept it as it is. So minus 1 by z. This can be expanded. So like this summation form. Here we have kept as it is. Plus this is your expansion form. Starting from n equals 1. Because the condition is starting from 1. That's the reason. So f of z is given as the same thing I written, 1 by z plus summation over n equals 1 to z to the power minus n. Suppose we are going for another term. As I said, z lies between 1 and infinity. We will go for n equals 2 now, the second one. We have found out for n equals 1. We will try for n equals 2. You can also try for n equal to 3, n equal to 4. Up to infinity you can try. So now, for that what we are going to do is, we are going to replace n as n minus 1. So replace n equals n minus 1. So that will give you the next term, n minus 1, n minus 1 equal to 1, n minus 1 equals 1. So n equals 2. Is it okay? You are going to replace this as n as n minus 1. n minus 1 equal to 1. So n equals 1 plus 1. n equals 2. So n equals 2. Replace n as n minus 1. Is it okay? So this can be written as z to the power minus n z, simply z. Simply z. Now this is for n equal to 2. After 1, 2, 3, 4 up to infinity. So this is for n equals 2. So earlier we did for n equals 1. Earlier we did for n equal to 0. So this is the idea. Okay, is it okay? Now we'll go for next problem. F of z equals z squared minus 1 divided by z plus 2, z plus 3 in Laurent series. With these two subdivisions, z is greater than, modulus of z is greater than 3, then z lies between 2 and 3. We are going to have two sections. Now, f of z is given by this function, z squared minus 1 divided by z plus 2, z plus 3. I am going to write this as exactly this term. 1 minus 5z plus 7 divided by z plus 2, z plus 3. How I have written? It is very simple. See here, z plus 2, just take the LCM. You just take the LCM. So that will give you z plus 2, z plus 3 minus 5z minus 7 divided by z plus 2, z plus 3. Now multiply these two. So that will give you z squared plus 3z plus 2z, 2 3s are 6, so plus 6 minus 5z minus 7. 3 plus 2, 5, 5z. This 5z will get cancelled. 6 minus 7 minus 1. So z squared minus 1. See? Z squared minus 1. So this term can be replaced by this term. It's easier for us, it's easier to have a partial fraction. This is very difficult, partial fraction. This is very simple. This also we can do it, partial fraction, doesn't matter, we will get the same answer. But this is very simpler idea. So we have now 1 minus 5z plus 7. So this function can be replaced by this function. Okay. Now we will first go with 5z plus 7 divided by z plus 2, z plus 3 using partial fraction. So a divided by z plus 2 plus b divided by z plus 3. We will have to find out the values of a and b. According to z equals minus 2, then z equals minus 3. So this equation can be written as 5z plus 7, which is equal to a z plus 3, b z plus 2. Suppose z equal to minus 2. You substitute here. So this term will go up. This term will have minus 2. So this becomes 1. So a. What are this term? So what is the answer? Minus 2. Minus 2. What is the answer? Minus 3. So your a equals minus 3. Very good. Minus 10 plus 7. Minus 3. Minus 3 equals a. So a equals minus 3. Is it okay? Now we will go for z equals minus 3. This term will go up. This term will be minus 1. And similarly this term will be minus 8. So you have minus 8 which is equal to minus b. So b equals 8. Is it okay? Minus 15 plus 7. You will get b as 8. So substitute here. So you have a equals minus 3 and b equals plus 8. Is it okay? So now z squared minus 1 is written as exactly like this. We have found out this value only. We have found out this value, partial fraction. You have to subtract by 1. So 1 instead of minus, you have to subtract this. So this will become plus. This will become minus. So this is the entire function. This is your f of z. We have found out only for this. We have found out only for this. Okay. So we will have to subtract by 1. So this is the answer. Now it's easier for us to go for. First, this is the function. F of z is simplified as exactly like this. Now, z is greater than 3. So this can be written as 3 divided by mod z less than 1. Okay. So now f of z equals, same function I have written, 1 plus 3. You just pull z out. So that will give you z 1 plus 2 by z. Similarly, minus 8 by, just pull z out. That will give you z 1 plus 3 by z. Okay. So 3 by z. You just take this term to the numerator, that will be minus 1. Just take this term to the numerator, that will give you minus 1. Now this can be written in terms of power series, binomial series. See, we have written in terms of binomial series. See here, 1 plus 3 by z. This is in terms of power series. This is in terms of binomial series we have written. See. So 1 plus, in summation form, we can write this as summation form, we can write this as a summation form like this. So that's the answer for the first one. Now mod z lies between 2 and 3, the second one. So 2 less than mod z means 2 divided by mod z will be less than 1. Similarly, mod z less than 3 means mod z by 3 less than 1. So you'll have to go with now two things. We'll have to have small technique. So f of z is given as this. Okay, 1 plus 3 by z. Okay, you are going to write, you are going to pull z out. So z 1 plus 2 by z. Now this time you are going to pull 3 out. It is not z. See, in the earlier case, we have, in both the things we have pulled z out because 3 by z is less than 1. Now in the second case, 2 by z is less than 1. Z divided by 3 is less than 1. It is not 3 by mod z is less than 1. Don't forget. There is a difference. You have to understand. It's very simple technique. 2 by mod z is less than 1. In this case, mod z divided by 3 is less than 1. So that's why I have pulled 3 out. In all the cases, we have pulled z out. Now we have pulled 3 out. Okay, understand? It's very simple. So 3 divided by z. As usual, you can expand in terms of binomial series, and minus 3 by minus 8 by 3, 1 plus z by 3 to the power minus 1. Okay, so look over here, it is 2 by z. Here it is z by 3, all because of this. Is it okay? All because of this. Mod z by 3. Here it is 2 by z. That's the reason we have pulled 2 out. We can pull 3 out, we can pull z out. It all depends on the conditions given in the problem. Okay, so now as usual, you have to expand in terms of binomial series, you have to expand in terms of binomial series and this like this, and you can write in terms of summation form. So 1 plus 3 by z, this is your summation form, and minus 8 by 3, this is your summation form. Any doubt? So now we expand 1 divided by z squared minus 3z plus 2. So z lies between 1 and 2, and we are going to do the problem with Laurent series. Okay, so f of z is given by this one. You have to factorize this one. Z minus 1, z minus 2, you can factorize. Immediately you can conclude that z should lie between 1 and 2. See here 1 and 2. Because z equal to 1, z equal to 2 here, we know already, z not. Now as usual, you have to go only with the partial fraction. So 1 divided by z minus 1, z minus 2 will be a divided by z minus 1 plus b divided by z minus 2. So taking the LCM will give you this. So substitute for z equal to 2 and substitute for z equal to 1, you will get the values of a and b as usual. So you will get, putting z equal to 1, z equal to 1, that will give you a value. Okay, a will be minus 1. So minus a will be 1. So a equals minus 1. Putting z equal to 2 in the equation, we will have 1. So b equals 1. So we can simplify this as minus 1 divided by z minus 1, a as minus 1 and b as 1, 1 divided by z minus 2. So we can write exactly like this. I have written with a minus sign later, that's all, at the next term. Now, what is the condition? Z should lie between 1 and 2. So it means 1 less than z can be written as 1 divided by z less than 1. And here z divided by 2 is less than 1. So surely the number should be pulled out. Here surely the z should be pulled out. That's the idea. Okay, we'll see. So f of z is written exactly like this. So now we have pulled, see, number 2 out. So 2, 1 minus z by 2. Now we have pulled z out. 1 minus 1 by z. According to the condition. See, according to the condition. So 1 divided by, here minus 1 divided by 2, 1 minus z by 2. I have written the same thing. Same thing I have written. And take this term to the numerator to the power minus 1. This term to the numerator to the power minus 1. And this can be expanded in terms of binomial series, power series. You can write this as, and this can be written in terms of summation form. So we written summation form. Simple idea. Okay. Now we will go for the next problem. Z divided by z plus 1, z plus 2. by Laurent series at a point z equals minus 2. It's given us. So z equal to minus 2 is a singular point. Okay, where it fails to have analytic function. That's called a singular point. We can't differentiate. At the point z0, we can't differentiate. That point is known as singular point. So z equals minus 2 is a singular point. Okay, so we'll have to expand z divided by z plus 1, z plus 2 about z equals minus 2. So we are going to expand. Now, the small technique that we are going to use is, you just keep z plus 2 as u. Z plus 2 as u. So z equals u minus 2. So z divided by z plus 1, z plus 2 can be written as, instead of z you substitute u minus 2. So u minus 2. Z you are going to substitute u minus 2 plus 1. Z plus 2 can be written as u minus 2 plus 2. So you have u minus 2 divided by, this is u minus 1, this will become u, so u minus u multiplied by u. Now you just separate in terms of partial fraction. That's the idea, it's simple idea. So just you are going to use partial fraction a by u plus b divided by u minus 1, and you have to substitute the corresponding one. So u equals 1 and u equal to 0. So u equals 1 means u minus 2. The left hand side is u minus 2. So u minus 2, which is equal to a u minus 1 plus bu. So if u equals 1, this one will go out. You can find out the value for b, which is equal to minus 1. If u equal to 0, get the value for a using this expression. So u minus 2 equals a u minus 1 plus bu. U equals 0 means this one will go up. You have a equals 2. So get the value for a as 2, and we have obtained the value for b as minus 1. Okay. Now what is given in the problem? It is z minus 2 is given. So z equals minus 2 is z plus 2 equals 0. It means mod of z plus 2 is less than 1 according to the problem. Is it 1? So z plus 2 is nothing but u. So mod of u is less than 1. Okay. So u minus 2, this term can be written as exactly like this, 2 by u plus, here I have brought to the numerator 1 minus u to the power minus 1. U is less than 1. So that's why we can write like this. We should not write this one. So this is for u equals 0. That is for u equals 1. So that we should write only this one alone. So 1 minus u to the power minus 1. So this can be expanded. Here I have written exactly like this. 2 by mu minus 1 by u minus 1 can be written as minus of 1 divided by 1 minus u. Is it okay? See, this is the expression that we have obtained. Minus 1 to the minus 1 by u minus 1. But I have written, see, I have taken minus sign out. All because of 1 minus u. Here it is given as less than 1. So that's the reason. So now it is here 1 minus mu. Mu is less than 1. Otherwise it will become negative. Okay, so 2 divided by mu plus 1 minus u to the power minus 1. So this can be written in terms of binomial series like this. Okay, so this is equal to, instead of u substitute z plus 2. Instead of u substitute z plus 2. Okay, that's all. That's the idea. Any doubt? We will go for the next problem. F of z equals e power az divided by z minus 1 whole squared in Laurent series at z equals 1. So z equal to 1 means singularity. There is no differentiating the point. So f of z equals e power z divided by z minus 1 whole squared. So z equal to 1 is a singular point. Okay. To expand f of z is a Laurent series about z equal to 1. It's enough to expand f of z in powers of z minus 1. Okay, we are going to do. So we are going to keep z minus 1 as u. So z equals u plus 1. So e power z can be replaced by e to the power 1 plus u. This z minus 1, z equals u plus 1. So z minus 1 equal to u. So u square. This we can separately write e to the power 1 e to the power u divided by u square. So e divided by e to the power 1 is nothing but e. So e divided by u square, e to the power u can be expanded. E to the power x. In the last video lecture, we did the series. That's why I said we have to learn by heart at least some series. Especially e power x is very, very important. Can you remember in the last section e to the power z we expanded. So here it is e power u. Now you just multiply by 1 by u squared. So we have pulled e out as well. So multiplying by 1 by u squared, that will give you 1 by u squared plus u divided by u squared plus u squared divided by u squared 2 factorial goes on. This is as it is. Take it off one thing. So 1 by u plus 2 factorial plus u by 3. Look at the term. U is not here. Where is u is here in these terms? See, in this term u is in the denominator. Here u is in the numerator. Look at here. So this must be your principal part. This must be your regular part, because this will go only with the negative powers, because u will be in the numerator with a negative one. This must be Laurent series. Immediately consider. So u is replaced by z minus 1. So z minus 1 whole square. Z minus 1. This is as it is. This is z minus 1. This is positive power. This is what? Negative power. Negative power is nothing but principal part. Okay. The combination of negative power and positive power, that will give you Laurent series. Expand the following in Laurent series about z equal to 0. This is first question. Second one, third one, fourth one. Very simple ideas. So z minus 1 e to the power minus 2z. You keep it as it is, z minus 1. Expand it. You just expand. E to the power minus 2z can be expanded like this. Z to the power minus 1, it can be written as 1 by z. You write it as it is. You multiply this one. 1 by z multiplied by the terms in the bracket. So that will give you 1 by z minus this one. Z will cancel. You have minus 2, and taking the common term, you will get this. So this is your first problem. We will go for the second problem. Z minus 1 sine 1 by z. So as usual, sin z minus 1, you just take it as it is. Sine 1 by z can be expanded like this. So in the last video lecture, we could see sine z. Can you remember? And cos z. Here it is sine 1 by z. Sine 1 by z can be expanded like this. You multiply this one, this, you will get this series. That's the answer. For the third one, z e power minus z squared, you just keep z out. Z to the power minus z squared can be expanded in terms of binomial series as like this. You multiply with z, will give you this. So this is the answer. Okay. 1 minus cos z by z. You keep it 1 by z common out. 1 minus cos z, 1 minus cos z can be expanded like this. Okay. Now 1 and minus 1 will be cancelled. 1 by z multiplied by this one will be this. So that's the answer for 1 minus cos z by z. The last one. Okay. So zeros and poles. The last section. We know that the roots of the denominators are nothing but poles. Can you remember? We have equated to 0. Whatever the denominator, we have equated this one to 0 to find out the poles. For example, 1 divided by z minus 2. You just make z minus 2 equal to 0. Z equal to 2 to find out the pole. We have used the denominator is equal to 0 to find out the poles. Suppose we are going to make the numerator equal to 0, what we call this as zeros. Zeros in complex number. I repeat, if the denominator, the roots of the denominator are nothing but poles. The roots of the numerator is nothing but zeros. For example, f of z equals z square plus 1 divided by 1 minus z square. Okay. So what is given? We will have to find out the zeros. So roots of the numerator. What is the roots of the numerator? Z square plus 1 equals 0. So z square plus 1 equal to 0. So z square equals minus 1. So z equal to plus or minus I. So this is your zeros. Make the numerator equal to 0, and what will find the solution? Find out the root. Those roots of the numerator are called zeros. Find the zeros of f of z equal to sine 1 divided by z minus a. So sine 1 by z minus a, which is equal to 0. We know that sine pi equal to 0, sine 2 pi equal to 0, sine n pi equal to 0, we know already. Okay, so 1 divided by z minus a, sine 1 by z minus a can be written as I'm going to bring this sign that side, so that will give me sine inverse of 0. 0 is nothing but sine n pi. Instead of 0 you write sine n pi. Sine inverse and sine will get cancelled. 1 divided by z minus a is nothing but n pi. So z minus a equals 1 divided by n pi. Your z will be 1 divided by n pi plus a. So this is the 0 of the problem. Find the zeros of 1 minus e to the power 2z. So 1 minus e to the power 2z equal to 0. You substitute. 1 minus e to the power 2z equals 0. E to the power 2z equals, okay, 1. 1 can be written as e to the power I2n pi, which you have already learnt in the introduction of the complex number. 1 can be replaced by e to the power I2n pi. So now equate the powers. Equate the powers. So 2z equals I2n pi, striking 2 common out, z equals in pi. What does it mean? Z equals 0, z equals plus or minus I pi, z equal to I2 pi goes on. So they are all zeros. That's all. So far we have finished series, the second section in complex numbers. Second series, Taylor series and Laurent series are very lengthier. We have solved a lot of problems on Taylor series and Laurent series, which are very, very important in solving analytic functions in terms of infinite series. Suppose if there exists some negative numbers, we call this as Taylor series. If it is positive number, we call this as Taylor series. If it is negative number, we call this as Laurent series. Okay, so put together this is nothing but power series. So we'll see in the next class. Thank you, students. Bye.